Ever wondered how fire sprinklers know how much water to release? In this video, we break down the sprinkler K factor and explain fire sprinkler flow with simple, real-world examples by MEP/Fire Protection Engineering.
Before we talk about fire sprinkler flow, we need to understand one key term. What is a K factor? The K factor defines how much water a fire sprinkler discharges at a given pressure. It represents the sprinkler's orifice size and is critical for hydraulic design. In simple terms, a bigger hole means more water.
Why is the K factor important? It controls the water flow rate from each sprinkler, affects the pressure required from the fire pump, determines pipe sizing throughout the system, and ensures the required water density is delivered at the fire. Wrong K factor equals under or over designed system.
Now, let's look at the basic sprinkler flow formula. Sprinkler flow is calculated as Q equals K times the square root of P, where Q is the flow rate in liters per minute, K is the sprinkler K factor, and P is the pressure at the sprinkler measured in bar.
Let's understand the meaning of high versus low K factor. A low K factor sprinkler has a small orifice. It discharges less water and requires higher pressure to operate. A high K factor sprinkler has a larger orifice. It delivers more water and can operate at lower pressure. Now let's look at some common sprinkler K factors and how they affect flow. K80 sprinklers are typically used for light to ordinary hazard areas. K115 sprinklers are common in ordinary and industrial occupancies. K160 sprinklers are used for high hazard and warehouse applications.
Now, let's look at an example with the same pressure, 1 bar. The square root of 1 is 1. For a K80 sprinkler, the flow is 80 liters per minute. For a K115 sprinkler, the flow increases to 115 liters per minute. And for a K160 sprinkler, the flow becomes 160 liters per minute. Same pressure, but very different flow.
Now, let's look at example 2, where the pressure is 2 bar. The square root of 2 is approximately 1.414. For a K80 sprinkler, the flow is about 113 liters per minute. For a K115 sprinkler, the flow increases to approximately 163 liters per minute. And for a K160 sprinkler, the flow reaches about 226 liters per minute. Higher pressure means more flow. The key takeaway is this. At the same pressure, a K80 sprinkler delivers less water, while a K160 sprinkler delivers almost double the water. This shows why selecting the right K factor is critical for effective sprinkler design.
Choosing the correct K factor has a direct impact on sprinkler system performance. The right K factor helps meet NFPA density requirements, reduces pump size, saves energy and cost, and ultimately improves fire control. Engineers tip: always match the K factor with the hazard classification, design density, and available pressure. Never select a K factor randomly. It can compromise system performance and safety.
The K factor is the DNA of a sprinkler. It determines how effectively water will fight a fire. If you found this video helpful, give it a thumbs up, subscribe for more MEP and fire protection content, and comment below if you'd like to see NFPA examples or site-based calculations. Thank you very much.